Now let's start second topic of the quantum mechanics, in which we are solving the previous year question of CSIR-UGC net. So the second topic is commutator. So in this part, we will solve at least 10 questions. So we will divide this video in two parts. Maybe 5 question first part, 5 question second part. So without wasting time, let's start to solve the question. So the first question is, first question was asked in December 2012. The question is, given the usual canonical commutation relations, the commutator A B of A is an operator given in the form of position and momentum, and also B is given in the form of position and momentum. So we have to find the commutation of A and B. So the solution will be here A, commutation of A and B will give I x py minus y p x, and for b y p z plus z p y. So solving this equation will give, you can take I outside of the equation, so it will give x py y p z plus I x py z py minus I y p x y p z minus I y p x z p y. So we can use a trick here. Here in second part, you can see the position is given by x and z, but momentum is given by y, uh, py. So from commutation relation, x I p j will give I h cat delta I j. This is iota. Okay. So here position is x z, but momentum is y. So this will turn to 0. And again similarly, position is given by y, but momentum is of px and pz. So this will again 0. So solving this will leads to x py y pz minus I y px z py. So again we can look into this. We can see that momentum is given for py and pz, and position is given for x and y. So only the term contribute is x py y pz. All other terms will be 0 from the same uh, commutation relation, this. And again in another term, again we get z y py px. So this will give I x pz I iota h cat minus I z px iota, sorry, here this is minus I h cat, and this will give y py I h cat. So further reducing, it will give h cat xpz plus h cut zpx. This will give sorry, this is h cut. So h cut, we will take h cut as common, pz plus zpx. So look at the answer. Looking at the answer, the answer is C. Now let's move to the second question. So this question was asked in June 2013, and question is, if the operator A and B satisfies the commutation relation, so the commutation of A and B will give identity, and where I is the identity operator, then we have to find the value of e to the power A, B, commutation of e to the power A and B. So we can write e to the power A, B. So using Taylor series expansion, we can expand e to the power A as I A 1 by 1 factorial plus A square by 2 factorial plus A cube by 3 factorial plus higher order terms and B. Now we can write it as I B plus A B plus A square by 2 factorial B plus A cube by 3 factorial B and the higher order terms. Now first term will give 0. This will be 0 because identity AB minus BA, so IB minus BI will give 0, and this is already given in the question as identity. So now this third term, so what will be the third term? A square by 2 factorial B, in simple form it can be written as 1 by 2 factorial A B. So again we can write it as just change the bracket, type of bracket. So we can write it as AB plus AB A. So as it is already given identity, so we can write it as 1 by 2 factorial. So A square B is reduced to twice A. So this can be written as finally A. Now again we can go to the fourth term, this A cube part. So we can write A cube by 3 factorial B. So this can be written as 3 factorial A square A B. So 1 upon 3 factorial A square AB plus A square B A. So this is identity, and from the previous term we get A square B. For A square B we get 2a. So this is reduced to 2a. So we can write 1 upon 3 factorial a square plus twice a square. It will give 3a square by 3 factorial. Further reducing, it will give a square by 2 factorial. So simply we can solve for the higher order terms. We'll give a cube by 3 factorial, a to the power 4 by 4 factorial, and so on. So we can write now the final solution as e to the power a b is equal to, first term is 0, second term is identity, third term is a, fourth term is a square by 2 factorial, and simply we can write higher terms a cube by 3 factorial plus a to the 4 by 4 factorial. So this series is the Taylor expansion of e to the power a. So we can simply write it as e to the power a. So now look at the solution, and here the solution is a. Now let's go to question number 3. This question was asked in December 2014. The question is, let x and p denotes the coordinate and momentum operator satisfying the canonical commutation relation xp is I. So in natural units ℏ, as we know xp gives IH. So here we have in question it is given that ℏ is equal to 1. So then the commutator xp e to the power minus p is, we have to find the commutation of x and p e to the power minus p. So the solution will be x p e to the power minus p can be written as p x e to the power minus p plus x p e to the power minus p. So it can be written as, so this term xp is I already given in the question. So this is I e to the power minus p plus, now second term can be written as x, and this can be written in the form of Taylor series expansion. So we can write I plus, sorry, this is minus p plus p square by 2 factorial minus p cube by 3 factorial, and so on. Now it can be written as x I minus x p plus x p square by 2 factorial minus x p cube by 3 factorial, and so on. Now again, this is 0. Commutation with any operator with identity will give 0. And xp is I already given. So we can write it as minus I plus, here xp square by 2 factorial. So we can write 1 upon 2 factorial. Xp square will give after solving, as previously in the previous question we have already solved, twice I, and this is p squared, so this will be give 2p, and I will come from xp. So twice ip plus, from here we again get x 3 ip square by 3 factorial, or this will be minus. So further on higher terms, now again e to the power minus p, taking minus I as common and multiplying p to this bracket term. So it will give p minus p square plus p minus p square. So no, just keep it here. I e to the power minus p minus ip, just keep it here, 1 minus p 1 minus p plus p square by 2 factorial. Here this will be reduced to 2 factorial, and again minus pq by 3 factorial, and so on. So this can be written as I e to the power minus p minus I p, and this is e to the power Taylor expansion of e to the power minus p. So this is e to the power minus p, taking I p common, 1 I e to the power p, sorry, you can take I e to the power minus p common, and it will give 1 minus p. So let's see, I e to the power minus p, 1 minus p, 1 minus p, this is the term I e to the power minus p, 1 minus p. So solution is A. Now let's move to question number 4. So question 4 says, so this question was asked in June 2015, and it says, if Li are the component of the angular momentum, this is the component of angular momentum, where L the then operator L, then the operator. So we have to find the solution of this operator. So here we can take I for I is equal to 1, x 2, y, z 3, z. So to find the solution, we can just expand it first. So the question is I is equal to 1, 2, 3. We can write L Li. So expanding it, we can get L Lx plus Ly plus Lz. So just first, so all terms are similar, we can see. So if we find the first term, we can similarly analogically say produce the second term and third term. So just focus on the first term. So here Lx is, we can write Lx I cap plus Ly j cap plus Lz k cap, expanding Lx and further. So again we open this term Lx I cap plus Ly Lx j cap plus Lz Lx k cap Lx. So this term is 0 as Li Lj commutation I h cat Lk. So where I is not equal to j, and this is cyclic term. So it follows the cyclic property. And here Ly Lx will give. So further, let's reduce it. So this will give this will give I minus I h cut Ly Lx Lz j cap plus Lz Lx will give I h cut Ly k cap Lx. So let's take I h cut outside. Minus Lz j cap plus Ly k cap and Lx. This can be further written like just take minus here Lz Lx j cap plus Ly Lx k cap. So we can write again I h cut. This will give Lz Lx will give I h cut Ly. So minus I h cut Ly j cap plus Ly Lx will give minus I h cut Ly Lx Lz k cap. So again multiplying I h cut to the internal part, it will give h cut square Ly j cap plus h cut square Lz k cap. And similarly, second term will give Ly will give h cut square Lx I cap plus h cut square Lz k cap. And third term Lz will give h cut square Lx I cap plus h cut square Ly j cap. Adding all these three terms will finally give, take h cut square common. Twice Lx I cap plus twice Ly j cap plus twice Lz k cap. This will twice h cut square L. So the solution will be Yes, twice h cat was square. Sorry, solution will be this D. Here h cat we have considered here the h cat. This h cat is taken as 1. Now let's move to next question, question 5. So in this question we can see here this question were asked in June 2016, and the question says if Lx, Ly, and Lz are the components of the angular momentum operator in 3 dimensions, the commutator Lx, Ly, Lz may be simplified too. So we have to simplify this commutation relation. So we can write here Lx, Ly, Lz is equal to. So we can apply here a simple trick. Like we know Lx and commutation of Lx with Lx will give 0. So we will break it in 2 parts. First part and 2 other parts. So this one part will be 0 and other part will be left out, which is a more simplified form. So we can write it here as Lx, Ly, Lz plus Lx, Ly, Lz. So this part will be 0. So we are left with only this first term. So we can now write Lx. Again we take Ly outside. Lx, Lz plus Lx, Ly, Lz will come outside. Now we know Lx, Lz minus I h cat Ly and Lx, Ly I h cat Lz. So again we can write Lx, Ly minus I h cat Ly plus Lx I h cat Lz. So taking I h cat outside, we are left with minus Lx Ly square plus Lx Lz square. So simplifying it will give I h cat Lx Lz square minus Ly square. Now looking at the solution, here I h cat Lz square minus Ly square. A is the solution.